everyone, welcome to Mr. Naik Math. By the end of this video, you will know how to find the greatest common factor and how to factor expressions using the basic strategies of grouping, decomposition, and difference of squares. Now before we start factoring, it is worth reviewing what is a factor. A factor is a number or expression that completely divides another number or expression. Every number or expression has at least two factors. These are 1 and the number itself. For example, 60 has factors 1 and 60. As for the other factors, they can be obtained by finding prime factors. This is a process known as prime factorization. So to make a prime factorization of 60, let's make a factor tree. 60 can be broken up into 6 and 10. Now 6 can be broken up into 2 and 3, 10 is 2 and 5. And so we can write 60 as 2 times 2 times 3 times 5. So how can we use the prime factorization to find all the factors of 60? Well, any combination of the prime factors would be factors of 60. For instance, all the prime factors themselves are factors of 60, like 2, 3, and 5. But even combinations of these factors, so for example 2 times 2 times 3, which is 12, is also a factor of 60. 2 times 2, which is 4, is also a factor of 60, and so on. Now while finding the factors of a number, you must be careful not to repeat the factor more than it is already repeated in the prime factorization. For example, if I were to say 2 times 2 times 2 times 3, that would give me 8 times 3, which is 24. And 24 is not going to be a factor of 60. So I can repeat 2 at most twice when I'm trying to find the factors of 60. Let's move on to finding factors of an expression. Again, every number or expression has these two factors always, 1 and the number or expression itself. So 1 and x to the 4, y to the 5. As for the other factors, we can perform a similar analysis. X to the 4, y to the 5 can be broken down into x times x times x times x times y times y times y times y times y. But the most irreducible factors of this expression are x and y. The other factors can be obtained by coming up with a combination of these two irreducible factors. For example, x squared y squared, x cubed y to the 5. Remember that we should not repeat a factor more than it is already repeated in this tree. So we cannot go like, for example, x to the 7, y to the 8. This would be incorrect. Now the next one might seem a bit tricky because there are plus signs, minus signs, and exponents all over the place, but this shouldn't change our approach. Again, every expression has 1 and itself as one of the factors. So we have 1 and this expression, which is x minus 3, x minus 2 cubed, x plus 1 squared, and x squared plus y squared. Now if you imagine making a factor tree for all these factors, you will see that x minus 2 will be repeated 3 times, x plus 1 will be repeated twice. And so we can say the most irreducible factors of this expression would be x minus 3, x minus 2, x plus 1, as well as x squared plus y squared. Now the remaining factors can be constructed using a combination of these factors. For instance, x minus 3 times x minus 2 would be one of the factors. Now that we've seen what factors are, let's go over the most important aspect of factoring, and this is the greatest common factor. Now the greatest common factor can be found by making factor trees for each of these expressions. For example, let's deal with all of these separately. I'm sure you notice that 2, 3, x and y are common to each of these expressions. But to find the greatest common factor, we select the maximum number of common factors. For example, there are at most 2 2's common to each of these, like this 2, this 2, this 2 is common, and then there's another 2 which we can find in common. but we cannot find any more 2's in common because 60 has no more 2's left. We can do the same thing for 3's. Notice that all of them have just one 3 in common. And doing the same thing for x and y, we have 3 x's, I would say. And how many y's? All of them. So we have 5 y's in common. And this is how we find the greatest common factor. So let's write down greatest common factor, GCF equals. So how many 2's were in common? We had 2 2's in common. So we have 2 squared multiplied by how many 3's did we have in common? Just 1. So 3 to the power of 1. How many x's did we have in common? 3 x's. So we have x to the power of 3. And finally, we had 5 y's in common. So we have y to the power of 5. And therefore, the greatest common factor is going to be 2 squared, which is 4 times 3 times x cubed times y to the 5, which is 12x cubed y to the 5. Now that we've learned how to find the GCF, let's see how we can factor some basic expressions. Consider the first example, 3a squared minus 6ab. Now our first step is to find the greatest common factor between these two terms. If you remember, to find the greatest common factor, we have to break this down into a factored tree. So let's do that. 3a squared, 6ab. Both of these have 3 in common as well as an a. And so the greatest common factor of 3a squared and 6ab is 3a. Now to factor something means to express it as some sort of multiplication, something times something. We're going to express this as a multiplication of the greatest common factor times some other factor. Now to figure out what this other factor is, we need to divide each of these terms by the greatest common factor. When you divide 3a squared by 3a, we just get a. And when you divide 6ab by 3a, we get 2b. And remember, there was a minus sign here, so this minus sign stays here. Another way to think about it is you can divide negative 6ab, treat negative 6ab as one term, and dividing negative 6ab by 3a, we just get negative 2b. And that's how you factor 3a squared minus 6ab. Now, it is really important to be extremely comfortable with both finding the greatest common factor as well as factoring expressions like this, because very soon we'll be factoring much more complicated expressions like the next one. So, our first goal is to figure out what is the greatest common factor. Now, I recommend you pause the video and try to figure out what the greatest common factor is yourself. Ready? Now, if all your calculations were correct, you should have got the greatest common factor to be 5bx squared. Now, how do we use this to factor this? Same as above, we pull it out of the expression and divide the first term by 5bx squared. Doing so yields a squared x. Dividing the second term by 5bx squared, we get negative 3a. And dividing the third term by 5bx squared, we should get negative 4b. Whenever we are done factoring, it is always worth checking if what we have factored is correct. And the best way to do this is to actually expand out our expression, since factoring is the opposite of expanding. So for example, for the first one, we can check by expanding 3a times a minus 2b, and we have 3a times a minus 2b. Expanding 3a times a and 3a times negative 2b, we do get the original expression, which is 3a squared minus 6ab. You can also perform the same check for the next example. Now that we have the basics down, we are ready to learn grouping. Now, grouping is a factoring strategy that is useful when you want to factor 4 terms. Grouping only works when the ratio of the first 2 terms equals the ratio of the second 2 terms. For example, the ratio of 4x squared and negative 8x is, let's find out, 4x squared over negative 8x should give you negative x over 2. And the second 2 terms, we have 3x minus 6. The ratio of these 2 terms, 3x over negative 6, is also negative x over 2. This suggests that we can use grouping. Now, if these two ratios were not the same, then it's a sign that we cannot use grouping here. Now that we know that this expression can be factored by grouping, let's see how to do it. As the name suggests, we break this down into two groups. The first two terms make the first group, and the second two terms make the second group. Now, from the first two terms, we factor out the greatest common factor of the first two terms. The greatest common factor here is 4x, and when you factor 4x out of the first two terms, we are left with x minus 2. Now for the next group, there is a very important nuance. Do you see there's a plus sign in the middle over here? If there's a plus sign in the middle, we always factor out a positive number. If the sign were a negative sign, we would have factored out a negative number. So factoring out a positive number from the second group, we have positive 3. Factoring out a positive 3, we just get x minus 2. As a quick check, these two factors need to be the same, x minus 2 and x minus 2. If these two factors are not the same, it either means that this expression cannot be factored by grouping, or it means that you've done your GCF factoring wrong. The next step is to notice that we have two real terms in this expression now. The two terms are 4x times x minus 2 and 3 times x minus 2. Both the terms, this one and this one, have x minus 2 in common. Factoring out an x minus 2 from the first term, dividing 4x times x minus 2 by x minus 2, we just have 4x, plus dividing 3 times x minus 2 by x minus 2, we have 3. And we have successfully factored this expression by grouping. Let's try a similar example to the previous one. Notice that the only difference between this one and the previous one is that the order of the 8x and 3x has been switched. Again, we know that it's possible to factor this by grouping by considering the ratio of the first two terms and the second two terms. The ratio of 4x squared and 3x is simply 4x over 3. And the ratio of negative 8x and negative 6 is also 4x over 3. Since these ratios are the same, we know that it can be grouped. Grouping possible. Alright, proceeding as before. We need to find the greatest common factor between these two terms, and that is simply x. When you factor out an x from 4x squared and 3x, we just get 4x plus 3. Remember, whenever there's a negative sign in the middle, we factor out a negative number from the second group. So factoring out a negative number from 8x minus 6, that would be negative 2. And again, we expect to get the same factor over here. Negative 8x divided by negative 2 gives 4x. And negative 6 divided by negative 2 gives positive 3. Now again, we're going to break this down into this group and this group. Each of these terms have 4x plus 3 in common, which we can factor out, and we're left with 4x plus 3 times x minus 2. And that is how you factor by grouping. We are now ready to learn how to factor trinomials. We're going to do this using the decomposition or the product and sum method. Now consider the following example. These numbers, you might notice they look a bit big and scary. So the first step is to always factor out the greatest common factor. You can verify that in this case, the greatest common factor is 12x cubed y to the 5. When we factor out this greatest common factor, 12x cubed y to the 5, we get 4x squared minus 5x minus 6. Now we are only going to work on the trinomial that's inside this bracket without really bothering about the greatest common factor that's outside. We expect the end result to look something like 12x cubed y to the 5 times something times something. And now our goal is to find what this is. So let's see how to get from here to here. Now I'm going to put this trinomial over on one side so that we can focus on what's going on. So we have 4x squared minus 5x minus 6. Now this is a very common organizational strategy that you can use in your own problems. When the main calculation is a bit involved, you can always do a side calculation on the side here so it does not affect your main work. Alright, so we have 4x squared minus 5x minus 6. The first step is to identify what our coefficients a, b, and c are. In this case, a is equal to 4, b equals negative 5, and c equals negative 6. They're coefficients because they are the numbers that are attached to our variable. Once we've identified a, b, and c, our next step is to find two numbers which have a product of ac and a sum of b. So product of ac and a sum of b. Let's see what that means. What is ac? A is 4 and c is negative 6. So ac is going to equal negative 24. So we want two numbers that have a product of negative 24. For instance, negative 1 and 24. Both these numbers have a product of negative 24. But what do they add up to? They add up to 23. We also want these two numbers to add up to negative 5. Now another guess might be 8 times negative 3. Now 8 times negative 3 is negative 24, but 8 plus negative 3 is not equal to negative 5. It's equal to positive 5. So a better guess and the correct one would be negative 8 and positive 3. Okay, just to quickly check, we have negative 8 times positive 3 gives us negative 24, and negative 8 plus positive 3 gives us negative 5. Alright, so what do we do next? How do we use negative 8 and 3? Well, we use this to split up our middle term. Our middle term is negative 5x, and so negative 5x can be split up into negative 8x plus 3x. Where are we getting the negative 8 and positive 3 from? From here, from this pair. Alright, we just split up the middle term, but the first and the last term remain the same, so we're going to write this as 4x squared minus 8x plus 3x minus 6. What do you notice? This is a 4-term expression, and 4-term expressions can be factored by grouping, as long as, the ratio of the first two terms equals the ratio of the last two terms. Turns out that this one can be grouped, and when this is grouped, the first group has a greatest common factor of 4x. When you pull out a 4x, you get x minus 2. The second group has a greatest common factor of 3. The sign has to be the same, x minus 2. And now we have two like terms which both have a common factor of x minus 2, which we can pull out, and we get x minus 2 times 4x plus 3. So we are almost done. Remember, our original expression had 12x cubed y to the 5 in the greatest common factor, and this had to be factored into something times something. Well, x minus 2 times 4x plus 3 is that something times something. And that is how you factor a trinomial. This procedure is a little tricky, but it's very important, and I suggest that you practice it by redoing this problem once on your own. Our next factoring strategy involves factoring binomials. Binomial factoring usually involves a difference of squares, and this formula is always going to hold true whenever there is a difference of squares, for example, a squared minus b squared. It's worth checking that this formula, that is a squared minus b squared equals a minus b times a plus b, is actually true. And remember how we check? That's by expanding. So let's expand a minus b times a plus b. Let's see what we get on the right hand side. We get a squared plus ab minus ab minus b squared. And the middle terms cancel, and we have a squared minus b squared. Consider the following example. Now at first glance, this does not look like a difference of perfect squares. But we know from experience that the first step is to always pull out the greatest common factor. So you can pause the video and try to find the greatest common factor. If you did everything correctly, you should have obtained the GCF to be 12x cubed y to the 5. Factoring this out of our expression, we have 12x cubed y to the 5. And inside the bracket, we are left with 16x to the 4 minus y to the 4. Notice that 16x to the 4 minus y to the 4 is a difference of perfect squares. And so we can split this up into 12x cubed y to the 5. 16x to the 4 is the perfect square of 4x squared. And y to the 4 is the perfect square of y squared. And this takes up our standard form a squared minus b squared. Using the factoring formula, we have 12x cubed y to the 5, 4x squared minus y squared, 4x squared plus y squared. So are we done? We are not, because there is another perfect square that we can factor within this expression. You notice correctly, that is 4x squared minus y squared. 4x squared is the perfect square of 2x, and y squared is the perfect square of y. So we can factor this even further, writing this as 12x cubed y to the 5. Now 4x squared again was the perfect square of 2x, and y squared was the perfect square of y. Now this is not a difference of squares, even though 4x squared and y squares are perfect squares, because there's a plus sign in the middle. To factor a difference of squares, there has to be a minus sign. Remember, difference only means subtraction. So we just leave this as is, 4x squared plus y squared. Again, 2x squared minus y squared can be factored into 2x minus y times 2x plus y. And so our final form, our fully factored form, is going to be 2x minus y, 2x plus y times 4x squared plus y squared. Consider the second example. The second example looks very similar to the first one. Notice that the first one was 192x to the 7 y to the 5 minus 12x cubed y to the 9. And now this one is 192x to the 7 y to the 5 plus 12x cubed y to the 9. The first step is always to find the GCF. And if you remember from the previous example, greatest common factor was 12x cubed y to the 5. And when you factor this out, we have 16x to the 4 plus y to the 4. Now, can this be factored using the difference of squares formula? No, this cannot be factored further. Cannot be factored further. This is because it's not a difference of squares. It's a sum of squares, not a difference. Let's summarize all the factoring strategies that we learned today. Always the first thing that we do is to factor out the greatest common factor. This is going to simplify your expressions greatly and make your life much easier. Once you factor out the greatest common factor, you can proceed to factor the rest of the expression. The first strategy that we looked at was grouping, and grouping is used when there are 4 terms. Grouping only works when the ratio of the first 2 terms equals the ratio of the third and the fourth term. Next, we learned how to factor 3-term expressions, also known as trinomials. The strategy for trinomials is to break down a 3-term expression to a 4-term expression, which can then be factored by grouping. The nifty trick here was to figure out 2 numbers that multiply to a times c and add to b. And finally, the last strategy we learned was the difference of square strategy for 2-term binomial expressions. We should always remember this only works when it's a squared minus b squared, which then becomes a minus b times a plus b, and cannot be used when it's a squared plus b squared. Now these are not the only strategies for factoring, rather they are the most basic ones, and we must master these before moving on to the advanced strategies, which will be covered in another video. As always, thank you for watching and see you in the next video.